Let's start by looking over the notes from the first half. Why is algebra important? Let's just glean a couple of ideas that you guys came up with from the video. Michael. It's related to real life problems. What else? Linta. Because you're going to use it in the future. Good. What else? Oscar. Right. Perfect. All right. What is the order of operations important? What did you glean from the video? William.
You could get the problem right, because if you did it from left to right, it's wrong.
Okay. Anthony?
It's important, the order of operation is important because if you have to do things in sort of a specific order before you can test and see if it works. And if you don't, it's not going to work and you're just going to fail.
Okay. Ricardo?
Yes. It is important because you use it because to get the right exact.
Okay. So looking at our rules for the order of operations. So these are the rules for the order of operations. Now, I think there's a lot of like mystical beliefs around order of operations, like, ooh, it's these order of operations. They just came to us. It was divine. This was the order of operations. Reality of it is, order of operations was decided a long, long time ago by a bunch of mathematicians, and they decided this is the way it's going to be because this is the way we say it's going to be. They could have very easily said the order of operations is Pemdas. You know, they could have changed the order of operations wherever they wanted. But what they did is they basically decided that a long, long time ago, they were going to choose the order of operations. They were going to set up these rules so no matter where you were in the world, if you have the same problem, everybody was going to get the same answer. Otherwise, without them, we could look at the same problem, and if we thought about the order of operations in different ways, we were going to get different answers. So mathematicians, thousands of years ago, came together and they said, this is what we're going to create for our rules for order of operations. So no matter where we are, we're always going to get the same answer to the same problem. So that's why we have order of operations. So the first rule of order of operations is what, Anthony?
First multiply, then divide before going to addition and subtraction.
Multiply and divide before add and subtract. So what we can kind of look about that is this is like multiplication and division before addition and subtraction. So I'm just kind of off to the side thinking about my order of operations in a slightly different way than the rules. Second rule that these mathematicians came up with, Mia? Parentheses before multiplication and division, or any grouping symbol before multiplication and division. And division. So that's my parentheses here. Last rule, Sadie? Okay, exponents before everything. I'm just kind of changing this a little bit, except parentheses. So if I'm looking at my ordered list I've got going on over here, I'm going to slide exponents right in between. So this is the way that the mathematicians thought about the rules for order of operations, and this is what most of us walk away knowing. This is our order of operations. It's PEMDAS. Now, you'll notice that I've written it slightly differently than maybe you did you've seen it written before. That's just because you should know that multiplication and division are really on the same level. Okay, if you have multiplication and divisions in a line, you can actually do the divisions before you do the multiplications. If you have additions and subtractions in the line, well, we're not even going to talk about that because we don't even do subtraction here anymore. So, but you could theoretically do them on the same level. One thing that I want to add to our order of operations, just things that we always think about. We always hate that subtraction so much that we want to do the leaf change switch. So, leaf change switch, I'm going to tell you, should happen after exponents. Leaf change switches should happen after exponents. The other kind of important piece that they don't really talk about here is what happens when you have fraction bar divisions. So if we're thinking about fraction bar divisions, like blah, 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 over blah, 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 blah. Fraction bar divisions have implied parentheses. Basically, if you wanted to rewrite a fraction bar equation, I could take this and basically rewrite it as this is. Here, let me fix that mess. Y times x. I can rewrite this as, in parentheses, y times x divided by x plus y. So when you have fraction bar divisions, you can rewrite them in the line if you want. But what's realistic to know is that it's like those parentheses are there. So we've talked about this before. You have to do everything on top and everything on bottom. Then you can do the division on the fraction bar. Mr. Ross. Huh? Yeah.
I was gonna ask, like, in the video it said that you must do multiplication and division first before you do addition and subtraction.
Yes.
But it also said that you must do it like in parentheses.
So it says you have to do parentheses first. So it's basically thinking about those three rules. First is multiplication division, so that's this piece down here. Then it's creating a second rule that says parentheses have to be done first.
So it's multiplication first and then parentheses?
No, parentheses first, then multiplications and divisions, additions and subtractions. In the video, they may have been talking about what happens inside parentheses. We're actually going to see a really good example that's going to talk about when there are parentheses and there's multiple things going on inside parentheses. So let's get that exponents review really quickly. This you should have labeled as an exponent.
I'm just asking a question.
I know, I'm just giving you a high five.
Maybe you know that one, Mr.
This is a base.
You want me to succeed?
What's your question?
You know, shouldn't we have good day, bad day before MD?
So good date, bad date, that's just when you're doing those single operations. Okay? So when you do that operation, just think about the good date, bad date. Alright? Yang. So it's replacing, replacing the variable with its value. So, when we were getting ready to substitute in, m sub c was what?
100, 100.
1,000. M sub p was?
100.
V was?
6.
R was?
3.6.
Okay. So the equation that they gave to us was m sub c plus m sub p times v squared over r minus 10.
Man, I said
The first thing we did was substitute in. So I'm labeling this first step is what happens after the substitution. F sub t is equal to 1,000 plus 100 times 6 squared over 3.6 minus 10. The next thing that we did was we dealt with some parentheses. So I'm going to put a P here. We dealt with this set of parentheses and we got 1,100 oops, times 6 squared over 3.6 minus 10. Now, this is where things get a little bit more complicated because we've still got parentheses to do. So our next step is still parentheses, but the parentheses we have to do have a lot of different operations in them. So that means we have to be following order of operations inside that set of parentheses. So inside that set of parentheses, what do we have to do first? Renee. Yeah, so do the exponents. So the way I'm going to label this is I'm going to say that I'm inside the parentheses, but inside the parentheses, I'm using exponents. F sub t is equal to 1,100 times the 6 squared is the 36 divided by 3.6. Oops.
No.
Minus 10.
No. What are you?
Next, we're still working with this set of parentheses because it's still there. We need to do an operation inside the set of parentheses. So I'm still doing parentheses, but what am I doing inside the parentheses? What operation am I doing inside the parentheses, Jacqueline? Division. F sub t is equal to 1,100 times 36 divided by 3.6 is 10. Sorry, that looks very much like a DD. P division. We've still got a set of parentheses, so we're still working inside the set of parentheses, and we are going to be doing now subtraction. Or you could have leaf change switched and said it was addition, either way. Whatever makes you happy.
What's the last one?
Now we have no more parentheses, and so we are following the rest of the order of operations. So after parentheses, we have exponents. There's no exponents. We move on to multiplication. Here we have a multiplication. F sub t equals 1,100 times 0, which is 0.
That doesn't make
And that was
sense.
multiplication. So the reason I have you do the work out the side is because this is our check for our work. If I look simply at this work over here, I'm going to make sure that this follows order of operations. I can't do anything out of order here. It's got to go all P's, then any E's, then any M's, or D's, then any A's or S's. Same thing inside the set of parentheses. I've got to double check that that was in correct order of operations. Any P's inside the parentheses, any E's inside of the parentheses, any M's or D's inside the parentheses, and any A's inside the parentheses, okay? So that work off to the side is number one. It's part of that proving it that we've talked about is one of those things that's really going to push our understanding and really up our map scores. It's also part of being able to check your work. So let's look down here at another example. Here we have an order of operations problem. What's the first thing that we need to do inside this order of operations problem? Oscar. Parentheses. Now I see two sets of grouping symbols here. I see the brackets and I see the parentheses. Which one are we doing?
Parentheses. No.
Andrea. Well, trick question. We're actually doing both because we're inside the grouping symbol
And then inside
and we're doing the parentheses. I'm doing the 6 plus negative 2, that's going to be 4. 3 times 4 plus 4 plus 3 squared. Now I still have a grouping symbol that I have to deal with. So inside that grouping symbol, I need to continue to follow order of operations. So what's the next operation I need to do inside this grouping symbol, Mr. Espinoza? The exponents. Three squared, that's 3 times 3 is 9. Still inside that grouping symbol because it hasn't been all sorted out yet. I still need to follow order of operations. Herbie? Add. this is probably easy enough. I can go ahead and do this all in one step. 4 plus 4 is 8, plus 9 is 17. And I've done everything inside the grouping symbol, but the grouping symbol also acts as an operation symbol because we have a number next to that grouping symbol, which Oscar is showing me with his arms crossed, is a multiplication. So the next thing that we need to do, we have an addition and a multiplication following order of operations. We now need to do what?
Multiplication.
Multiply. Multiply. 3 times 17 is 51. And we only have one operation left. That's our addition. 2 plus 51 is 53. So again, we're looking over here to check our work, making sure this is all order of operations over here. Grouping symbols, grouping symbols, grouping symbols, multiplication, addition. That follows order of operations. Inside parentheses, exponents. There was no multiplications or divisions, additions, and subtractions. All correct order of operations.
Yay.
Okay. So let's go ahead and hit our key points before we move along. Genesis?
Put a star for substitution.
All right, she wants to put a star and then put its match over here by substitution. I like that. Mr. Espinosa? Always follow order of operations. I'm actually going to put a box around this down here.
I already did.
And I'm going to put my little, I'm going to do a triangle in a box as my symbol for that's my other key point. Triangle in a box.
It could have just been.
Which is the coolest toy ever. A triangle in a box.
But you can't get it out.
Dude, I know. That's why it's a fun toy. Mr. Posey, any other key points? Yes, sir. Okay, and so he's kind of saying whatever he answered down here. Let's do a square and a circle. It's not as fun of a toy. No, I promise you, it's not as fun of a toy.
There was a toy.
Okay, so